Welcome to another part of our SQLite offline app with SvelteKit journey. And I was busy the last weeks. I visited a conference, and so now I'm resuming where we left off. And the last part, we downloaded data to our storages here in the SQLite database, so it's now full of data, and now we need to actually use it in our app and query it. So, but first off, as you see when we reload the page here, it's not instantly. So basically what happens first is we load a worker, we initialize the SQLite module, then we check for each storage if it needs some data. And even if it's empty, it downloads some data. But what I want to turn out here is that it takes some time till the storage is ready. So till we can actually load any data. And as you can imagine, if we have to download a lot of rows first, it can even take seconds. So we need a kind of system to tell our app, okay, the storage is now ready. You can now query the data from it. And so we jump into the code base here, and let's look how we can do this. And so so we have this init storages file here, and I propose that we do a kind of promise-based system where we can tell this file, we want to be notified when our storage is ready. So first off, we start with where's the init storage function here, with a set of storage that are already ready. So if we call it a later point when it's already set up, we can use that. And a map that stores any callback, an array of callbacks. So we can fulfill all the promises when the storage is set up. And so we create a function called storage is ready here. We get storage ID. We add to the set the storage ID, so we know it's ready. And if there are any callbacks in this map, we then go through them, iterate through them, and for each we call the callback. And this function we need to call, and this is the init storages function, and this basically sets up the storage. It downloads the data if there is none, and what we can do here is after we set up the storage, or each storage, we can call the function here, storage is ready. And now we need to add another function, that's the consumer function. Basically the app can call to get notified when the storage is ready. I call it wait till storage ready. We pass again a storage ID, and we return a promise. And if it's already set up, the storage, so if we call it on a later point where the storage is already ready, we have it in this set here. We can immediately resolve the callback. Otherwise, we add the callback, the resolve callback, to our map with the callbacks. And so basically at a later point when this function is called, it will then resolve the callback. Yeah, I forgot to add a small line here that's rather important. So here in the part where we go through each callback and execute it, we have to afterwards delete all the callbacks in there because we already processed them. We don't need them anymore. So we can test this out. We can go to our app page. Yeah, this is for now the default page. We can here add a script, and we change the content here. We say storage ready. We just display a true or false. We need to, of course, add the variable here. And yeah, for now it's of course always false because we don't update the variable, but we can add an on mount here. Need to import that. And yeah, when the component or the page mounted, then we can run some JavaScript. So we can wait till the storage is ready. And we have to give the storage ID. So we defined customers or order details here. And when this is done, afterwards, basically, we update this to true. And as you can see, it already in the background, it actually updated the value. And if we reload, you can see it flickering. So it takes some time, a few milliseconds, but then it's ready. Great. So now we need to add functionality. So we want to display the data on this page that we have in our storage. So we need to add a functionality to basically allow querying for data. And for that, I'm going to first go here to this types file in the SQLite folder. And here we define all the worker messages. So again, when we communicate from the app to the SQLite worker, we defined these message types. So the SQLite worker knows what we want to request and then can respond with a response here. And for each type of request, we define new message types here. And I'm going to add query and query response. And we also need types for the request and the response. So in the request, we will send an SQL query string, and in the response, we get rows or an error message here. Great. So I add here in the SQLite folder, I'm going to create a new file. I call it, not a folder, a file. And I call it data_api.ts. And this function is of type, I call it run query, and it receives the SQLite string, SQL string, and I'm promising basically an array of rows. So that's the type we defined, that's a data row. And in there, we just going to send a message to the worker. We need to import all this stuff here, all the types. And as it's a plain SQL, so we can basically query any table or any storage we have defined. This hasn't a specific storage, so we can, I just put a string in here, generic. And if this is done, we can get the response data. We can check if there's an error message. If there is, we throw this error, otherwise we return the rows. Okay, great. So this is only the outer function that we can call. We actually still need to do the implementation in the worker. And in this main file, we have this huge switch where we go through each message type that we can receive. And of course, we need to add a new one. Here, that's case, and it's worker message types dot query. The end we break, and in there we're gonna call a function, and I call it handle query .ts here, and this one receives the worker message with the subtype of the query information, so basically the SQL statement, and returns as response. And we do a try catch first, So if any error occurs during execution, we can then log the error and return this error message. And let's start with logging the SQL statement here, and then we can go ahead and can say const data is db.selectObjects, pass the query, and we then can go ahead and return. And that's already it. So we just plainly gonna execute the SQL statement. If the user passed an invalid statement, it should be catched here and return the error message. Great. So back in the worker, we need to call this thingy here. So let me quickly copy it. Here, query data equals await handle query. And again, need to import the types. And then we're going to return the data to the main thread. Okay, now we need to call this actually in our app. So page.svelte here. And here we can, after this part, we can say const data is await run query. This is a function that basically just pipes our query to the worker and handles it when it returns an error. And we can for now just log the data. And if I go to the page, we can actually see here we receive the SQL query in the worker and we get back all our data. This is great. So we can also say, for example, limit 10, and then we get only 10 rows, and we can, this is great. So I see, I didn't reset the data, but as you can see here, basically every company has test, and that's a small problem our current approach has, is that it implies that it can only run a query, and here in the function we call db.selectObjects, but we can actually also pass data writing scripts or statements, like going comment that out and say update set company equals to, I have to change the kind to backticks, or I can use the single quotes, and say just where 1 equals 1, and then we can maybe we can just move that down and say data 2 and data 2. And what we see here is now first we receive an empty array from the update, and we now have updated the company columns for each row of the table. And I think, the point is it's client data, so it's only in the user SQLite table. So of course the user will be able to manipulate that data. There's nothing we can do to work against it. Even the user could download the database and do offline changes and upload it back to it. But I think we should still try to make it as hard as possible, because this is, I think, too easy to just pass an update statement here. And a small counter measurement we can actually do here is we go to the handle query thing here, and what we're gonna do is wrap this in a transaction. To b.transaction, this will receive a callback that just executes the statements, and we need to actually define the data array first and then just set it in here. And what this thing does is it sets up a transaction, and if in the callback, if it goes through without throwing an error, it will also commit the transaction, but when it throws, it will do a rollback. So I'm just gonna always throw in here and throw a new error, force callback, force rollback. And because we don't want to run in this catch every time, I'm gonna catch that throw out of here, but it still causes the transaction to roll back. And if error message is the same, if it's not this, we will throw it still. So if there is an error in here, we still want to get notified, but if it's our planned error, I would say, we just do nothing with it and silence it. So we basically by this force a rollback by inserting an error in there or throwing error in there. So I need to define this function. I have it in the lib, I think. Lib, util. I do it here because we can use it in many different parts. It's just a small function because TypeScript doesn't. We have to do a check if errors instance of error to get error.message, and where we just do a helper function, so we don't have to manage the error every time. Okay, so now if we go back to our page, we can then say XYZ, and what we do see here is we now can't update this anymore because we roll it back basically. And for example, if we do an error in here, we still get our error message. Great. If you have any better suggestion, it's kind of hacky, I think, this approach with wrapping this in a transaction, but as far as I know, there is no API from within SQLite that says, yeah, just run this query in, or this statement in read-only mode or something. So this is just my solution. If you have a better one, please please let me know in the comments. Thanks. So back on the page, we can first off delete this part where we try the update, and in here we will show the data. So let us first do a small array where we store them. We've already typed them out for the database part, and we then say customers equals run query, and this now returns this arrays. Okay, and we can then just it's fairly not really styled out or anything. I do a div, and we get all the rows here. And so I'm gonna fix the names by deleting the files and basically downloading them again. So now we actually get the real company names again from the server. Great. So another small thing I want to do is to provide an easier to use API than the query one, because I guess many people like to use ORMs that offer an easier interface to query the data, and also makes things like pagination or searching stuff more easy because you don't have to write the SQL yourself. Instead, we provide an API that makes it easier. So we add another message type and call that query storage, because it's only working on a specific storage, so you can't do cross storage stuff with that. And we going to add the request, and here we can define a few parameters, like offset is for pagination you want not the first rows, 10 to 20 for example. With limit we can then do pagination, order by, and also a search term, so we can do a full row search. And we're going to add that in the handle query section. And I'm quickly gonna paste the whole code and go over it. Don't worry, it's a little bit complicated, but I guess it's not really necessary to understand everything. So let me quickly import these. And so we start off with the base query. We query from the table, and we have these placeholders for a where clause, an order by clause, and a limit clause. And if the user passes an order by setting, we then set it to order by a column name, also a limit, and so we replace that then with a limit. And if the user also has an offset, so offset doesn't make sense without limit, so we need either. And the more important stuff is the search term, or the more complex stuff. And we have a small helper function that helps us set this up. So what we do in here, we call this pragma on the table info. We basically get it's like a query on the table. So here this is executed. We get all the columns on the table. And we need that because we want the column names, so we can basically concatenate all the columns after each other. And we also do a call list that's just saying if it's null, we just do an empty string, because if we don't do that, we can get problems with null values. And in the end, we say the whole concatenated row into one string. We compare it with like operator, and then our search term, gets placed in the percent signs, so it can be anywhere in the text. It doesn't have to be the beginning or the whole thing. And we escape all percents in the search term with the slash. And we also do lowercase to both parts. Okay. Then we also put the where in there. We're gonna log the query and then execute it. Okay. We have to, of course, call that function. So we can simply do that with following code. Great. We of course need to provide an API, so we can call it from our Svelte code. And also what we can do here is we do the wait till storage ready in here, so we don't need to call it anymore. We can't do it in here because we just paste any SQL and we don't know which storage is needed in there. So for this, the user has to explicitly wait for the storage to be ready. For this, because we go only on one storage, we can just wait for it in here. And even if it's set up, this immediately resolves. we send the request, get the response, and return it, like with the other call. So let's go to the Svelte page, and in here we can then we can remove this part, and we're gonna replace it with this call. Let's first pass an empty object, and it's as customer. Import the function, and we should now we have an error. Module does not provide an exponent run storage query. Where is it? I have maybe forgot to save some parts. So yeah, okay, this now works. So we get every rows. We can say where's this here? Say limit to 10 again. So we get from Alfred's to bottom dollar markets. We can say then offset 20. So we should get different rows. Great. We can do order by call. And what columns do we have? We have it's currently by company. So let's say contact. So EFF. Yeah, that sounds right. Great. We could also say order by here is desk. We need that comma. So it's the other way around. Good. And it's also different values because we do the order by and then the limit and offset. And at last we can gonna remove that and do a search term, and that's what can we search for? Paul. Yeah, so we get Paula, and here the ones who don't have anything directly in here, those still have it in a row. So we can actually Sao Paulo is the one here. In the future we can maybe extend this, so we can maybe say a search term. We can say, okay, which columns do we want to apply that or something else. But this is just, I think, an easier to use API, so we can do some basic stuff with that without writing any SQL by ourselves. So yeah, this is it for this part. It's this is getting to be useful as we actually now see data. I think in the next part I will do the offline capabilities. So for now we are still online. So if I go here and say network offline, of course nothing will work because we don't have any caching or stuff. So we will do that in the next part with the service worker, and so we can still use our app when we're offline. But for now, this is it. If you have any feedback, any suggestions, please share it in the comments. Please rate or like or dislike the video, and see you soon. Have a nice day. Bye.